The photoelectric experiment. I also like to think of it as the light electricity experiment, because that's what it is, and that's what photoelectric means. So we start with a ray of light, and I'm just going to replace it so we can fix up Mr. Sunny. And this ray of light comes down and hits a piece of metal, which is surrounded by electrons. And we can think of this piece of metal as like an electron prison, because it holds all those electrons to it. Luckily for our little electron, it gets a hand from our ray of light, which helps the electron break free. How it does this is by transferring some of its energy so the electron can escape its orbit around the piece of metal. Not all the energy is used up, however. Some of it's left behind, and the electron gets to keep this and take it on its journey. What it does is it converts it to kinetic energy, otherwise known as movement energy, and we get to measure this along our electronic highway, which is also the circuit on the end of the piece of the metal. We put an ammeter as shown, and Mr. Ammeter actually sits there and counts how many electrons go past, so that we can measure and know how many electrons go through. That's our current. We also chuck something else into our circuit here, to make life a little bit harder for our electron. We put some voltage. Let's call it Mr. Voltage. Actually, Dr. Voltage is a better name. And Dr. Voltage's only job is to figure out how much voltage it takes to stop the electron. So for a slow-moving electron, all it does is it puts a bit of a potential across it, a bit of a negative, positive, so the electron gets repelled. But if the electron's moving really fast, well, Dr. Voltage is going to need to lift his game, so he hulks up and increases the voltage to stop the fast-moving electron. And this is how we use our voltage to tell us how much kinetic energy an electron has. Anyway, to summarize, we start with a ray of light, which hits our metal. It then frees the electron while using up some of the energy. The electron takes the leftover energy and goes through our circuit, which we measure with an ammeter and a voltmeter. One more time. Ray of light, frees electron, leftover energy, which is stopped by our voltage. And some really smart people took this idea and put it into an equation, which is our beginning energy, or our energy of our ray of light, equals our work function, which is how much energy it takes to free an electron, plus the energy the electron has, the kinetic energy, which we measure in electron volts. Anyway, that's our photoelectric experiment. Ta-da!